In a typical layered or tiered application design, there are separate logical and sometimes physical layers. For instance, it's very common to have a user interface layer, a business logic layer, and a data access layer. Oftentimes, these will each correspond to separate projects in Visual Studio. The nice thing about this approach to design is that it supports encapsulation and abstraction. It also works at the application level that is appropriate to each layer. Each level should only know about one level deep, if possible, because this allows for the individual layers to be swapped out at a later date without affecting the layers above it. This provides a good unit of reuse, but the lowest levels are generally the most reusable because there are many more layers above them than, for instance, a user interface layer, which is typically not reusable and usually is at the top of the dependency hierarchy. This diagram shows an example of the traditional or naive layered architecture approach, with the flow of dependencies going from top to bottom. As you can see, the user interface is sitting at the top here, and it's depending on a business logic layer that makes up the main central area of the app. And most of the business logic layer classes are going to end up calling data access layer or common assembly classes. And the data access layer or some kind of service layer is going to talk to the database or talk to services. If the dependency flows in this direction, and since we know dependency is transitive, this means that the user interface is always dependent on the business layer, and the business layer is always dependent on this data access layer, which in turn depends on the existence of a database and services in order for it to function. What this means is that your application is very difficult to test or change or work with in isolation from a database or these services because of this hard dependency that's flowing from the business layer through the data access layer. This means also that we are not depending on an abstraction, rather we are depending on an explicit instance of the data access layer which we're going to be working with. We can invert this architecture so that the thing that sits at the bottom of our dependency structure is instead the object model, the core, the domain objects, as well as perhaps our business logic and services. These can be packaged together as a single assembly or separately if you prefer. It's also important to note that any of the dependencies that these have are represented by interfaces at this layer. Next, the other areas of the application, such as data access, user interface, tests, I/O operations, and web services, or WCF, would all be on top of this and would depend on these services and objects. Infrastructure concerns outside of our application, such as the database or web services themselves, would reside off to the side, where only the data access module would depend on it, or the WCF or web service module. But note that our business logic and core domain objects would not have this dependency, and as a result, they could be tested without having to have these in play.